All right, so the next thing I want to go through is the half-angle identities down at the bottom of the page here. So we're going to work out a couple of examples using half-angle identities. I've got the half-angle identities recorded over here, so I want to talk about what you would do on this. So the first thing that you want to do is double this angle in order to use the half-angle identity. So double 22.5, you're going to get 45 degrees. Okay, so we're going to write this as the cosine of 22.5 degrees is equal to the cosine of 45 degrees over 2. And then we'll be using the cosine half-angle identity, which I have right here, okay, at the bottom of the page. All right, so the first thing that we have to do is you got to talk about that plus or minus in there. So let's go ahead and get this put into this identity. So what we'll have is plus minus. We'll just write plus minus for now. Then we have 1 plus the cosine of 45 degrees all over 2. So that's the identity. And when you're working with this, you want to remember that this angle alpha in this formula is the 45, not the 22.5, say, okay? Now, the next thing is, well, what's the deal with this plus minus? Well, the original angle, 22.5, is in quadrant 1, and every quadrant 1 angle is positive, so that means we're going to have a positive answer to this problem then. Okay, so you got to just figure out what's the answer to the problem. Is it negative or positive based on the quadrant of the original angle? Now we can go to the unit circle and we can easily look up the cosine of 45, which is square root of 2 over 2. So we would end up having positive, and then it would be 1 plus the square root of 2 over 2, all over 2 like that. All right, and then you have a complex fraction. We want to get rid of that 2, so go underneath the radical, multiply both the top and bottom by 2, and then you'll end up having this then. Okay, so we're just going to have, and be careful how you do this distributive property. 2 times 1 is 2. Don't forget to do that. And then if you take 2 times the next thing, 2's cross out, so you get square root of 2. Don't forget about that 2 times 1. You're distributing. Then the bottom would be square root of 4. Okay, and then to finish this up, you basically want to just divide this up, do the square root of the top and the square root of the bottom. Then you got your answer, okay? So the answer to the problem, I'm just going to write like this, is square root of 2 plus square root of 2 all over 2. So that should be the answer to the problem. So I want to also show you on problems like this that they're pretty easy to verify on your graphing calculator. So you want to make sure that you're in degree mode, and if you go cosine 22.5, that will give an approximate answer. We'll just compare it to the exact answer you got. So you can go square root of 2 plus square root of 2, and you need to get out of that radical and then divide by 2, and you should get exactly the same answer. So it's easy to verify in a graphing calculator. Okay, the next problem is the half-angle identity for sine. So again, we start this off the same way. You want to just double that angle. It's okay that it's a negative angle. Ain't going to make any difference. So that is negative 315 degrees. So we want to go ahead and write this as the sine of negative 157.5 degrees is equal to the sine of negative 315 degrees all over 2. All right. So now what's going to happen is we're going to use the sine identity, and here's the sine half-angle identity, which is just has 1 minus cosine instead of 1 plus cosine. All right, so this goes in like this. So let's go ahead and let's just write it down. We have plus minus square root 1 minus cosine of negative 315, and then all over 2. Okay, so that's how that goes. And again, I want to emphasize again to you that how the angles go in here. The idea is this angle, alpha in this formula, is the 315. not the original angle. Okay, well, the next thing we've got to consider is, well, what quadrant are we in? Okay, if you have a negative 157.5 degree angle, that's clockwise, so that will end up being quadrant 3, and the sign is negative in quadrant 3, so that means we're just going to get a negative answer to this problem. Okay, so we got that worked out. Now we just need to work this out. So we're going to have a negative, and we'll have 1 minus. Now we need to look up the cosine of negative 315. So negative 315, just count it out. All the way around the circle, clockwise, is negative 360. So 315 would end up terminating at pi over 4, or 45 degrees. Okay. So what we need to do on this, if we do the cosine of negative 315, that's just square root of 2 over 2 again. So we get this all over 2. Now we're all set up. Again, go under the radical, and you want to get rid of the 2, so multiply by 2 over 2, and this will work out like this. So you'll have negative, and again, 2 times 1 is 2. 2 times radical 2 over 2 will just give you radical 2, and then the square root of 4 you'll have like that. Okay, break it up into 2 parts, and then we'll end up having negative square root of 2 minus square root of 2 all over 2, because you can do the square root of 4. Okay, I'm going to write that step. You can do that in your head, of course, but you would have that. Okay, so the final answer we're just going to write is negative root 2, the square root of 2 minus the square root of 2 all over 2. Okay, that would be the answer. And again, that's a real simple thing to verify on your graphing calculator. So let's do that one more time. So if I do sine negative 157.5, like that, that'll give an answer. Check your answer, which is negative square root of 2 minus square root of 2, all divided by 2, and just compare and see if they're the same, and they are. Okay, so you can tell with 100% that you're right. Okay, so let's move to the next thing, and the next page we're going to work with a tangent identity, half angle identity. So the one thing that's real important about the half angle identity for a tangent is there are 3 forms of it, and this last one is the easiest to work with. So, you don't want to go use that one or that one. You'd still get the same answer. It's just algebraically they turn out to be more complicated. So we're going to use that one right there. So again, we start off this problem just by doubling this angle. And when you double it, you should end up with an angle that's on the unit circle. So that is 225 degrees. Okay. So what we have here is we're just going to write this as the tangent of 112.5 degrees. That's the same as the tangent of 225 over 2 degrees. Now the nice thing about this identity, you don't have to worry about the plus or minus. It'll just kind of work its way through this identity. So what we're going to do is we just do 1 minus the cosine of 225 all over the sine of 225. So again, when you're doing this identity, again what you're doing is the angle alpha, and I think I have got a variable messed up in this formula. That should be that x should really be an alpha. Okay, so we have that. So we're all set up and we're ready to go. So if I take my unit circle, I'll bring this unit circle down just to refer to here. We're ready to rock and roll with this thing then. So the cosine of 225 is negative root 2 over 2. The sine of 225 is negative root 2 over 2 also. So now we can go ahead and plug this in. So we'll end up getting this. We'll have 1 minus negative root 2 over 2 all over 1, or no, sine. Oh, come on. Erase. There we go. Okay, and we'll have sine of 225 is negative root 2 over 2. So we just need to algebraically simplify this. So this is 1 plus root 2 over 2, and then the bottom is negative root 2 over 2. So you do have to do a couple of things on this. You need to multiply by 2, top and bottom to get rid of the 2. All right, and I'll bring this over here. Okay, so what I have is this. Okay, so 2 times 1 is 2. The 2's cross out when you multiply that, so that'd be root 2. In the bottom, you'll just have negative root 2. Now you want to rationalize the denominator. So you can multiply either by a negative root 2 or a positive root 2. It doesn't make any difference which way you do it. So I'm just going to multiply by negative root 2, top and bottom. Okay, and then when I do this, I'm going to have, again, I'm doing a distributive property, so I've got negative 2 root 2, and then minus square root of 4, and then the bottom I have a positive square root of 4 like that. Okay, so this is negative 2 root 2 minus 2 over 2. Then what you can do is just divide that up into 2 parts. So you would have negative 2 root 2 over 2 minus 2 over 2. So it looks like the final answer would be negative root 2 minus 1. Okay, so there's a lot of algebra going on that problem that you have to work with. But that is the easiest identity to work with, so use the third form of that. And then again, it's pretty easy to verify your answer on a calculator. So if I just go tangent of 112.5, I do get a negative answer because this is the tangent. Come on. Sometimes I can't put stuff in the calculator right. Okay, so we got that, and this is quadrant 2. The tangent's negative in quadrant 2, so I get a negative answer. So if you type in your answer, negative square root of 2, and then minus 1, you get the same thing. So it's like the other problems, it's easy to verify. Okay, so let's see. Let's move to this next part. And so this one is more work on the half angle and double angle identities, but now you're given a triangle. So it's kind of your SOHCAHTOA stuff here. So you just want to remember, you know, the SOHCAHTOA on the right triangle. Okay, so to do the sine of 2 theta, you want to just write down the identity. The sine of 2 theta, you have to use the identity, so that's 2 sine theta times cosine of theta, like that. Now you go to your right triangle where I have all the 3 sides, and then you can just fill this in. So the sine of theta is opposite over hypotenuse, so that's 8 over 17. The cosine is adjacent over hypotenuse, so that would be 15 over 17. Okay, so just using your right triangle trigonometry definitions, and now you can put the 2 over 1 and you can just go straight across. Use a calculator if you need to then to do that. Okay, so we can go like this. We just have 2 times 8 and then times 16 is going to be 256, and then 17 to the second, or 17 times 17, is going to be 289. Okay, so the answer to this problem would just be 256 over 289. So it's all about using the identity. Okay, all right, and then the cosine of 2 theta, remember it's the one that has 3 forms of the identity. You have cosine squared theta minus sine squared theta. You have 2 cosine squared theta minus 1. You have 1 minus 2 sine squared theta. It doesn't matter which one you use, you're going to get the same answer. So I'm just going to use the first identity, cosine squared theta minus sine squared theta. And then again, it's just looking up on the unit, or not the unit circle, the triangle. The cosine is adjacent over hypotenuse, so that would be 15 over 17 squared. The sine would be opposite over hypotenuse, so that would be 8 over 17 squared, like that. Now just work out the arithmetic. 15 squared is 225. 17 squared is 289. 8 to the second is 64. And you've already got a common denominator, so to get the final answer, I'll just do 225 minus 64. Whoops. 225 minus 64, and that'll give 161 over 289. Okay, so it's just a matter of knowing the identities and, knowing the trig definitions. It's an exercise in getting comfortable with the identity, primarily is what it is. Okay, so the next one's just going to do a half angle identity on. Okay, and let's see, the half angle identity, I'm just going to take this thing that I had up here and I'm going to slide this down here. Come on, get down there. There we go. Okay, just to refer to. Okay, and then we'll put these things together, again, using the same right triangle. So when we do the sine of alpha over 2, we're going to have this identity here. Okay, so what we're going to have to start with, we'll just put plus minus, I think that should have been a theta too, not an alpha. So plus minus square root of 1 minus cosine theta over 2. All right, now the thing on here is theta is in quadrant 1. How do we know that? Because it's in a right triangle, and these two angles, theta, and these other two angles are of course less than 90 degrees, so that means we're going to have a positive answer. Okay, so what we do is we just do square root 1 minus cosine theta. Cosine again is adjacent 15 over hypotenuse 17. So we need to just work this out and simplify that algebraically to get the answer to that problem then. Okay? All right, so what we do on this is just go under the radical, and what we're trying to get rid of is this 17. So we're going to multiply by 17 over 17. Okay, and then we do this. What we're going to have is this would be square root of 17 minus 15 all over 34. Okay, so you're doing distributive property when you do that. So that would be the square root of 2 over 34. 2 over 34 reduces down to 1 over 17. Okay, you can do the square root of the top and bottom. So you would get 1 over radical 17, and then you really should rationalize your denominator to get that final simplified result. So now I just multiply by root 17 over root 17. So the final answer is square root of 17 over 17. Okay, a little bit more algebra involved in working with the half angle identities typically. Okay, so that'll give the answer to that. Okay, next problem is asking for the tangent of theta over 2. So again, you want to use this form. Use the third form, that's the easiest. So we just do 1 minus cosine theta over sine theta. So going to the triangle, the cosine is adjacent 15 over hypotenuse 17. So that's 1 minus 15 over 17. The sine is 8 over 17. Okay, like that. So let me write this a little cleaner. I've got 1 minus 15 over 17 all over 8 over 17. Okay, so what I want to do is I've got a complex fraction. You just want to get rid of that 17. So this is pretty simple to do. You'd have 17 minus 1. 17 times 1 is 17. Distribute times 15 over 17, you would get 15. And then the bottom, you would just have an 8. So you have 2 8s, which is equal to 1/4. So that would be the answer to that problem then. Okay? All right, so that's how you would solve that with the half angle identity. Okay, so all of those problems I was doing were just getting you comfortable with double angle and half angle identities. That's what I want you to be able to work with, is those type of identities. Okay, the next one we're going to look at is 9.5. 9.5 gets into the trig equations. So I'm going to copy this unit circle here, and we'll need to refer to this as we go through a lot of these trig equations. Most of these things are designed so that you can get the answer by interpreting the unit circle. So the first one's real simple. This one, you want to solve on this interval. So you want to find all the solutions to this equation in degrees from 0 to 360. Now this one, there's not really any work to show. You just interpret the unit circle. So cosine of x equals square root of 2 over 2. Well, you just want to look on the unit circle and identify where the cosine is root 2 over 2. Well, one place is here, the other place is here, and we want these answers in degrees, so our answers would just be 45 and 315. Okay, so you're just identifying the two angles in degrees where the cosine takes on that value of square root of 2 over 2. That's all you do on that one. Okay? All right, the next one you have to isolate. So you need to move the root 2 over to the other side. So I would have cosecant x equals negative square root of 2. Now the way I look at this is, if you have a cosecant, you can easily turn it into a sine. Okay, that's what I would recommend you do on this. The sine of x is just the reciprocal, so that would be negative 1 over root 2. It's just easier to work with a sine on a unit circle than it is a cosecant. Then I'd go ahead and rationalize the denominator. Okay, and if I do that, then I would get negative root 2 over 2. So what we're doing is we're really solving the equation sine of x equals negative root 2 over 2. So now it's just an interpretation of the unit circle. Identify where the sine takes on this value. And there's two places. There's here and there. The sine's the y value. So that means the degree answers would be 225, quadrant 3, and then 315. Okay, like that. All right? So what I end up having then is I end up having 225 degrees and then 315 degrees like that. All right? So that's it. So if you have a sine, then you want to change that like that. Okay? So change the cosecant to a sine, and then that would be the best way to solve that. Okay, so now the next thing that I want to take a look at is the next set of problems are the same kind of idea, except what you're doing is you're interpreting on the unit circle, but you're getting your answer in radians. So that's what's going to make this a little bit different. So let's go ahead and do these two problems then. Okay, so the first thing you'd want to do on this is subtract 2 from both sides. You would have 2 tangent of x equals negative 2. Then you would want to divide by 2. So you get tangent of x is equal to negative 1, like that. All right, so now we're just going to interpret on the unit circle. So remember, the tangent is y over x. So we're trying to figure out where y over x on the unit circle turns out to be negative 1. So what happens is the tangent is negative in quadrants 2 and 4. So you're just finding out, well, where would y over x be negative 1? Well, one place would be there, okay, because what would happen is if you did y over x here, you would have root 2 over 2 all over negative root 2 over 2, which would be negative 1. So one answer of this problem clearly would be 3 pi over 4. Okay, you go here, same thing would happen. If you do y over x here, you would also get negative 1. So if you're interpreting a tangent on a unit circle, then you essentially want to just figure out where is y over x going to give that value. So the two answers to this problem would be this then. Okay? And that'll take care of that. Okay, so now what I'd have is this. The next problem we're going to do, I think, a square root property on this. So this one, again, we're going to add 3 to both sides. So we get 4 sine squared x is equal to 3. Then we divide by 4. So we would have sine squared x equals 3 over 4. Now we're going to do square root property. And when we do that, of course, we're going to have sine x. Don't forget, this is real important when you do this, you have plus or minus square root of 3 over 4, like that. So you have a plus or minus answer, so you're going to actually get an answer in all 4 quadrants. So that would just be plus minus root 3 over 2. All right, so now it's just a simple interpretation on the unit circle. Okay, so I'm going to go around my unit circle and identify the angles in radians where the sine is equal to these values. So first of all, you would have one place would be here and there. That's where you would get positive root 3 over 2, but you would get negative root 3 over 2 here. Okay, so that means your answers are going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so the key on that one is you have that plus or minus because you're doing the square root property. So the answers are pi over 3, 2 pi over 3, 4 pi over 3, and finally 5 pi over 3. Okay, like that. All right, so that takes care of that type of equation. So this first type of equation is just kind of working with the unit circle in reverse for the most part. Okay? All right, let's go to this next page. And I'm going to polish this up with a few other examples here using kind of the same idea. Okay, this problem, the first thing you would do is subtract root 3 to both sides. So you would have 2 sine x equals negative root 3. Then you would divide by 2. So we have sine of x is equal to negative square root of 3 over 2, like that. And now what we're doing is we're finding all real solutions. Now again, the directions are important. All means don't just list the specific answers, have a formula for the answers is what you got to do. And since it's real numbers, that means radians. So this is a formula that you're looking for in this problem then. Okay? So it would go like this. Now really again, all you're doing is finding on the unit circle where does the sign take on that value of negative root 3 over 2. So it takes on that value at 4 pi over 3 and 5 pi over 3. But we write the answer this way. So you got to write the answer like this. The technical correct way to go is say the set of x so that x is equal to 4 pi over 3, but then you say plus 2 pi k, because that is another lap around the circle. That's just the period of the sign. 2 pi k is another lap around the circle. So you're just going to go infinitely around the circle, actually in both directions, clockwise and counterclockwise. Then comma, you say x equals 5 pi over 3, and then you say plus 2 pi k, and you do have to say k is an integer. You do have to have that statement in there. So that's how you would write the formulaic answer to that problem. Okay? So you got to know what the directions are telling you when to use a formula. Okay? So the next problem, same idea, add 4 to both sides. So you would have 4 tangent x is equal to 4. Divide by 4. And we have tangent of x is equal to 1, like this. All right, so what we would have here is when we go through this now, we would just looking on the unit circle, where is the tangent equal to 1? So again, we're kind of thinking, where is y over x equal to 1? So there's 2 places that happens. One place that happens is here. The other place it happens is here. So again, if you do y over x here, you would have root 2 over 2 divided by itself. So that would be 1. So that occurs at pi over 4. Same thing would happen here at this point. You would have y over x would also be 1, so that happens here. So what you do is you write a formula on this, and this goes like this. You would say the set of x, the first answer is x equals pi over 4, but this time it's not 2 pi k because the period of a tangent is pi. So every time pi goes by, you get another answer to this problem. So you say plus pi k where k is an integer, and you can use the abbreviation I taught you for an integer, and that's it. Now, one of the things we talked about with a tangent is it's not necessary to say x equals 5 pi over 4 plus pi k. That's not needed, and the reason is because of this. If you take this first answer, pi over 4, and you add pi to it, you're going to get this answer, because these things are 180 degrees apart. So notice if I get a common denominator on this, I just get pi over 4 plus 4 pi over 4, so that's equal to 5 pi over 4. That's why it's unnecessary to write that second formula. Okay, so that will kind of wrap up that type of a problem. And I'm going to post this video in several parts. So I'm going to go ahead and stop this and post this, then I'll push on and continue with the rest.